All right. So welcome to Texting While Driving from Zero to Hero. And we actually have only 25 minutes, so it's going to be in turbo mode. So Elm and Haskell. So that's PHP, actually. Who can spot the mistake? Yeah? Yes. There's another one. So, yeah, I have a typo over there. So here, I'll just jump. So indeed, I have a typo in the word message. I'm passing the node ID instead of the user ID because I'm just passing an integer. And the template, I'm just suggesting that there is no existing template and some existing template. And I have here in my speaker notes a note to myself saying, roll your eyes. And even for the people in the back, please watch. It's magnificent how I'm rolling my eyes. And I'm kind of want to retitle and repurpose my the title of the presentation and call it Get Out of Your Comfort Zone. I just want to say that from my perspective, Drupal has reached, Drupal is now in a comfort zone, right? And it's awesome business-wise, but in terms of technology and development, it's a bit, from my perspective again, a bit too much in a comfort zone. And the way I see it, the really interesting stuff, / the non-boring stuff, technically wise, are kind of happening when we are outside of our comfort zone. So in this specific presentation, I'm going to show you a lot of Elm code, and I'll try to do my best in explaining it. But there's going to be some value, actually, if you're not going to understand everything. And I'd like you to, when you see that you're not understanding everything, kind of try to tap into your inner newbie and kind of explore what you're feeling, because that's where some kind of growth and interesting things is happening. And this is kind of awesome, because for me it's going to be a win-win situation. If you understand it, it's awesome. If you don't understand it, I can still enjoy it. So, types and modeling the problem. Modeling the problem kind of in Elm or Haskell talk, it's the way of saying if there is a problem, we think about the types, the type system, and how we model it, how we build this kind of data structure, and everything else is kind of derives from that. It's kind of an implementation details. So jumping right into Elm types, we're going to see it quite a lot. So here's the type Boolean. It could be either true or a false. That's it. And I can define my own arbitrary types. For example, here I have my type DrupalCon, New Orleans, Dublin, Baltimore, and so on and so forth. And then I have my function getName, which is getting a DrupalCon type property. And obviously, there is the compiler. Whenever I'm going to pass it something wrong, it's going to bark at me. And I'm going to return a string. I don't have to write the types. Elm and both Haskell are inferred types. They understand it by themselves, but it's kind of considered a good practice. And for us as humans, we can really understand what is written over there. Because in the end, I don't really care about the body of the function. I really care about the type signature, what it's getting, and what I'm going to get back. So then inside the function, I have this getName, and then we have what we call pattern matching. So case DrupalCon off, and then if it's type New Orleans, then return some kind of a string. And again, if I have a typo or if I forget Vienna, then the compiler will not compile and it will show me an error message. Let's say, just for, I don't know, some business requirements, we actually want to differentiate between the DrupalCons, the one in the US and the one in Europe. In that case, I will create two more types, Con EU, I call it, naming is hard, but still Con EU, Dublin and Vienna, and the Con US. And then my type DrupalCon is now DrupalCon EU, which is wrapping another type called Con EU, and the same for the US. And then the function would look the same type signature. However, you'll see that we actually have two pattern matching over here. Case DrupalCon off, the first time I'll get maybe DrupalCon US, and the argument that I'm getting the Con US, this is actually this type, this Con US, which I now need to pattern match. Again, the compiler will not allow me to do any mistakes. So by having those types in place, I kind of indicate what I want, how I want to structure my application. So let's say we have some kind of a site that is showing different people and which DrupalCon they are attending. So I'll have this record, which is type alias. This is just an alias, right? I'm just saying there's a thing called person, which will have a property, the name would be string, and the DrupalCon property is of DrupalCon type. So for example, Tom, here is, I'm creating a new record, I call it Tom. The name is equal Tom, and DrupalCon equals Vienna. But obviously, one person could have attended several DrupalCons, so my record will change, and DrupalCon will be a list of DrupalCons. So in that case, Tom has attended Vienna and Baltimore, and Sue, she doesn't have any DrupalCons under her belt, so the list is empty. Let's continue. The business requirement says that we want to know and show if a certain person was a speaker in one of those DrupalCons. In that case, what I will do, I'll say, okay, I have this type alias called isSpeaker, which is just a Boolean, true or false. Just for readability, I'm saying there's a new type alias, which is isSpeaker. And then I have this DrupalCon dict. Again, this is just aliasing, just to make things a little clearer later on in the application, which is actually a dictionary, right? There's a thing called dict. In Elm, it's a dictionary. You can think about it like PHP when we have associative array, we have a key, which we can get, and then we have the value. I'm writing every dict over here because, really quickly, in Elm, a dict the key can only be some comparable, a string or an integer. With this every dict package, I can make it every arbitrary type, in our case, the DrupalCon. So it means that DrupalCon dict will be keyed by the DrupalCon type, and the value would be isSpeaker. So the person alias has changed as well. DrupalCon is now a DrupalCon dict, and then this is how it looks. So we'll start with Sue on the bottom. She has no DrupalCons under her belt, so it's every dict empty. It's completely empty. Whereas Tom, for example, we're just creating this dict out of the list. So we are saying, here is the list. The key is DrupalCon EU Vienna, and the value is true. The true means is a speaker, or not is a speaker. Who is slightly confused already? Great success. Even if you are, remember, hold, treasure that feeling. And the thing is that the key over here, I couldn't just write Vienna. I actually tried writing Vienna in the beginning, but then the compiler reminded me, hey, I don't know what Vienna is, because you told me everything is keyed by DrupalCon, which DrupalCon is DrupalCon US and DrupalCon EU. So let's continue. Let's say, again, from this site is actually getting the information about which DrupalCons I've attended through calling a REST API, issuing a GET method into API DrupalCons. Then in that case, when I just initiated my application, maybe, I don't know, I got information about the user, I know what's the username, but I don't know yet, I have not fetched yet the DrupalCon information. And this brings us to a very handy type called the maybe type. And this now already starts to look a little strange. What is this A that we saw? This A is representing some kind of arbitrary type. It could be integer, it could be string, it could be our DrupalCon. This is basically saying, listen, maybe you don't have nothing, and nothing is nothing. It's not wrapping anything. It's just nothing. And above it, we have just A, just your arbitrary value that you wanted. In PHP, we don't really know, we don't really have this notion, and this is why our code is scattered with those checks of isSet and not empty, because this idea of concept of saying that property is optional or required does not exist in PHP. Over here in Elm and Haskell, this is very, this is part of your data structure. You are saying, this one is going to be optional. So for example, I could structure my data like that and say the DrupalCon is actually a maybe DrupalCon dict. And this is something interesting. Both Tom and Sue, just for this example, have no DrupalCons, right? But we can already understand by their state that For Tom, the DrupalCon is nothing, and in this case, it signifies that I have not yet even contacted API/DrupalCon. I just don't have the information yet, right? And for Sue, I'm saying this is just an empty dict, meaning I contacted the server, I brought back the DrupalCon list, but it's empty. So if I wanted to show all the people that have not attended any DrupalCon, I would probably show just Sue, because about Tom, I don't have that information yet, and this is kind of encapsulated as part of the property. Now, what if I wanted to, I don't know, show a spinner or know if there was an error fetching, a HTTP request? I mean, I know that we always assume that what could possibly be wrong. Why wouldn't I get an answer from the HTTP, but in some obscure world, in developing countries, I don't know, not in our life, that could actually happen. So I could do something like that. I could say, okay, I have this person and the DrupalCon, this is a maybe, and then I'm going to have a loading property and I'm going to have a failure property, both are Boolean. Maybe it could work out, right? I could say for Sue, DrupalCon is nothing yet, and yeah, I see that it's loading and there's no failure. But that's problematic, because I could very easily, because I'm a human, do a mistake and somehow reach a state where I have both the loading here, you can see the difference, what I've done, it's both loading true and failure true. So what is it? Like, it's an impossible state, and this is kind of a phrase that we have with type system, and it's about making impossible states impossible. I don't want to reach a point where I could have this loading and failure true, because it's representing something that just could not be. And in case you weren't confused, up until now, this is probably a bit more confusing. So let's try to decipher what we have here. And this is yet, again, it's just a common pattern that raises, and we have like a package called remote data. Remote data is basically saying you have some remote data that you want to fetch. And it actually has 4 different states. It can be not asked. It could be, I just initialized the application. It could be loading. I'm in flight. I'm currently fetching the information, and then it can be a failure or a success. What are the E and the A? In the beginning, this is arbitrary types. We don't know exactly what they are, but they are different. The E is representing an error over here. You can see it next to the failure, and the A is representing the success. And just to specialize a bit this type, we have a thing called web data. Web data is just an alias for remote data, which is saying, I don't know what the value of a success would be, but I know what the error will be. And the error would be of type HTTP. So in that case, our person would look like that. So I have the name, and I have DrupalCon, which is web data wrapping DrupalCon dict. So for Tom, I don't need to say nothing, which is not enough. I can say not asked, or I can say loading. I know the exact state of the information that I'm getting from the server. And as for Sue, again, I get a success message, which is an empty dictionary. So this is from an application we're building in Gizra. It's called iHanagane project. It's basically an NGO in Rwanda for mothers that have AIDS, that are HIV positive, and they have babies, and they're coming to the clinic once a month or so to get some physical, checks and some consulting. So basically, every mother could have several children, and if you can see through the user interface, basically we're having different checks: weight, height, nutrition, uploading photos, and so on and so forth. And obviously, each mother can have different babies. And what you're seeing in this GIF is basically I have this existing examination for the child, for the baby, and obviously I had past examination, so I could know what the recent weight was, and I need to register the new weight. So just to understand the business logic for now, for the example, I have many existing examinations, but I must have one single new examination that I'm starting. I don't want to start like 2 examinations. Think of a piece of paper that a nurse might have. They don't want to like have 2 pieces of paper for the same kid. So before starting of thinking how to implement an HTML and whatnot, we're starting to think about the types. How can I represent this business need of saying I could have unlimited existing examination, but only single new property, and that's again with types. So I have this new type called storage key, and instead of writing A, I just called it record ID, so it's clear what we're dealing with. So I have existing, which is wrapping some kind of a record ID, maybe an integer, maybe something more complicated, or one single new. So just by writing those 3 lines, I'm guaranteed to have exactly what I want. And then it will look a bit something like that. So I'll have type examination ID equals examination ID integer. What's that? You remember in the beginning in the PHP, I showed you how I'm so elegantly passing the node ID instead of the user ID? Because, you know, it's just expecting an integer. But with the type system, I can have Typesafe values, and I say, you know what, that examination ID, which in the end it's just a node ID maybe, but sorry, from L perspective, it's not just an integer. This is an examination ID that is wrapping an integer. So on all my type signatures, when I'm saying I want to have an examination ID, I cannot suddenly pass a user ID or an article ID. So this is the type safety that I'm getting, and then I'd say type alias examination, again, a new record, which would be a weight or a height of type float, and then I build this slightly crazy, maybe looking dictionary, which is basically saying this is a dict or an every dict, like we saw earlier, and the key here is more involved. This is the storage key, the new or existing, which is wrapping the examination ID, which is wrapping an integer. So basically, we're stacking those types together, and the value is some kind of an examination, and the child will have this examination property. And just to show you that if we wanted to have, for example, like offline capabilities, saying we would like to allow the operator to enter many examinations even offline, meaning it's going to be saved locally to the local storage and only later saved to the backend, then still I could say I have only one new thing. And then I would model it and I just say type storage key with local, let's say. Let me pass a record ID, the one in the server. Let me pass a local ID, the one that I'm going to save locally, which is probably going to be just an incremental integer that I'm going to increment. So again, just by thinking those types, the entire implementation could change. And if I wanted to start with new and existing, just with the storage key, and later on refactor my code, I will just add this local new type. That's how I would start. And then I would just let the compiler make sure that I rewire my application accordingly with almost no cognitive load, because, again, the compiler is taking care of things. So we saw that we have this idea of, you know, entering the measurements, the height or the weight. Over here, we have a nice pattern called editable. So editable, look at it, it's getting type editable A. Again, a specific arbitrary type, which I don't know what it is. It could be read-only A, right? Or it could be editable AA, meaning it could hold 2 values, but the values could be different, but it must be from the same type. It could be a 4 and 4 or a 4 and 5, but it cannot be 4 and hello world. It must be on the same type. So we can see some examples. So if I have editable read-only, which is wrapping an old string, and I say, give me the editable value, I'm getting the response old. And if I have editable, which is old and new, and I want to fetch the value, I'm getting new. Meaning that same property, that same type is actually holding both values. And you know, when we're dealing with JavaScript and we're dealing with application, it's everything about holding as much state and controlling the state and knowing what information that you have. So basically, I could say, okay, I've started with a default value, let's say 4, and I'm typing 5 right now. And I want to hold that information, the 4 I want to hold until I'm saving it to the backend and got everything is working, unless somebody's clicking cancel, and then I will just revert back to the initial value. So then my examination could look something like that. Editable is wrapping the float. But the thing is that right now I'm actually holding only the old value and the new value, right? I typed 4, I typed 5, whatever. I'm holding that, but I have no notion of am I sending it to the backend, was it saved successfully or not? So for that, we can actually continue and stacking our types, and we have this a package called editablewebdata. Remember editable from literally 2 seconds ago? Remember webdata from 4 minutes ago? Now combine it in your brain, and this is what we're actually doing over here. So editable web data is getting some kind of A. So editable web data, the first value it's going to hold is actually editable of A, that arbitrary type, float, whatever we are using, along with web data. And those, how do we call it? Brackets, sorry. The brackets that you are seeing, we call it unit. It's just an empty value. I don't care about it, right? I'm not wrapping anything important. I just want to know the state, am I loading, success, or failure? So now it's going to actually look like that. So a weight or a height has all the information it needs to know about itself. Is it an old value? Is it a new value? Is it loading? Is it succeeding? And so on and so forth. Decoders. So basically, when I'm doing interviews for Elm developers in Gizra, my first question is, do you understand decoders? If the answer is no, is bye-bye. If the answer is yes, then I investigate a bit more. So the decoder is that all the guarantees we're getting from a type system is just because it knows exactly which kind of data it has. So I can no longer, like, if, you know, some crazy language, I don't know, let's think about something random, JavaScript. I have HTTP, I got the JSON, and I'm just assuming that everything is right. Over here, we have this notion of decoding. If I'm getting a JSON, I need to decode it and make sure it matches my different record shapes, aliases, whatever you're going to call it. So for example, I can say, I have this JSON x3, and I want to decode a field called x into an integer. I'm going to get a response OK3. Again, it's not just 3, it's an OK. I get a type which is wrapping, which is telling me, was it successful or not? If I have a longer JSON, still it's working. But if I'm passing it true value and I'm expecting an integer, I'm going to get an error. Again, the compiler will make sure I cater for those cases because it's otherwise, it won't compile. It's working for a string. And this is like a very simple example. But in the end, when you have like really bigger aliases, like we have a sale alias or whatnot, then in the end, I would have to do decoding. When I get the JSON, whatever the form is, I need to make sure that everything matches this type alias that I've had. So over here, we can see it's required, I'm expecting to see a label property of type string. If I'm not going to see that, then it's going to fail. It's not going to crash. There's zero runtime exception in Elm. But it will go to part of the code which is dealing with what happened if the decoder has failed. So Haskell, I decided not to talk about it much. It's for me to decide, apparently, so I will just run it really, really fast. Haskell is way more complicated from my perspective than Elm. Elm, I find there is some learning curve. It's a new language, but it's much more approachable. And actually, it made things that are happening in the browser, JavaScript, more predictable than Drupal. Let that sink in, right? Things that are happening in JavaScript, more predictable. Haskell is, from my perspective, more complicated, but again, after coming from Elm and seeing type system and compile system and starting to think that not working with those systems hardly makes sense, I've just started working with that. We don't have anything in production yet, but definitely dabbling with that. And here is a quick example. I have API/login token. I'm just, I don't know, sending some access token. And the way it will look, I'm using a framework called Yesod. So there's some magic involved. I could have done it in a more explicit way, but I'm using some magic. But what's interesting to see, for example, in the user is I'm saying a password is of type text, but this is a maybe, right? Just because, I don't know, that's the example. So again, from the minute I've defined something, I'm already very explicit if it's a required or optional, and I have this access token over here that I say belong. I have some arbitrary token and some user ID. I will define my routes, and then the handler would look something like that. And I don't expect you to necessarily know Haskell, but what's going on over here, and I'm saying, okay, you're required, I'm required to be logged in at this point, and I want to get the user ID. It's not just an integer. This is a user ID type. I cannot pass it to an article type. And then I'm going to run some DB query and bring me select something like where the user ID matches my user ID. And the answer that I'm getting is actually a maybe. Because again, I'm calling the database. Something could have gone wrong. So I cannot assume, again, PHP doesn't force us to assume it, and we forget it sometimes. But Haskell doesn't let us break from that. It's going to be a maybe value. That nothing and that just, and I'm returning it. And what I wanted to reach is the fact that actually when we have decoupled application, right, client side and backend side, then usually the places it breaks is obviously on the edges, on the peripheral, right, where we're sending the request or when we're getting that. So there is a nice implementation called the Elm export, where when I'm defining my data on Haskell, I'm actually adding this Elm type, which in turn will export the decoders that we've just seen into Elm, meaning there's a really tight connection between what I'm doing on Haskell side and on Elm side, and the chances of things breaking is being reduced. So Elm you could use in so many different ways. We have like Headless Drupal, where we have this auction, real-time auction sales that we are running, and this is like real-time with pusher and whatnot, like really fancy Elm. But it could be also like hybrid application. I expect you all to read Hebrew, but basically this is Drupal serving the page along with some tiny Elm application. So whenever I have those cards and I want to start filtering them, everything is happening in Elm. I don't do a special request to API/something. It's just Drupal passing on the information through Drupal add.js, and I just inject it into Elm. And we actually have unit tests for this searching over here, because I can do those unit testing in Elm, and I would never write any test for that, probably, if it was jQuery or whatnot. So Drupal is actually passing the data into the Elm. So even the translation that we are doing for those 3 cards over here, not of the content, but all the wrapping, which time are you opening or whatnot, even the translation is happening in a type-safe manner. Meaning when I add a new translation key, I cannot forget to translate it to Arabic or to English, because again, the compiler will not compile. And we have other examples, like, I don't know, our Jekyll site for the Gizra.com site. You won't see it on the phone, but if you go from desktop, then we have this about page, which is this theme page, which is like, I don't know, some Elm application. So for me, this is mostly not that you need to understand exactly what editable is, but just to repeat my previous remark about getting out of the comfort zone. I do hope that you were slightly confused, and if so, that you were able to tap a bit into that feeling, and I encourage you to tap more into that, because I do believe, honestly, this is where the interesting parts are happening. Boom. 2 minutes we have? I think we have like 2 minutes, so make the questions either Boolean or really, really short. All right, no questions, that's better. All right, guys, thanks. Cheers. I told you 27 minutes, and it was 27 minutes. Thank you.
Funny. I'm from Santa Cruz. And that red dot is from that.
Wow, I need to chill now.